amines are important functional groups in chemistry and in science as a whole. Nitrogen, of course, is located in group 5A. Therefore, it has 3 electrons to go in order to complete the octet. And that's why nitrogen makes 3 bonds. And of course, for the satisfaction of the octet, it must therefore possess a lone pair on nitrogen, on the nitrogen atom. This is the general structure for amines. Of course, primary amines. Of course, amines can be of different substitution patterns. Primary amines are possible. Secondary amines are possible. Tertiary amines. This is, for example, a primary amine. What makes amines very interesting is actually that lone pair. Now, this lone pair is on nitrogen. Of course, nitrogen makes 3 bonds. This lone pair on nitrogen, not only it makes amines nucleophilic, but very importantly, it makes amines basic. So this lone pair makes amines nucleophilic. It makes them also basic. And this basicity of amines is a very important property of amines. Amines are organic bases. Therefore, they can react, of course, with acids. Now, what's also very interesting is to discuss, of course, is the amine basicity. So how can we explain amine basicity, or how can we discuss amine basicity? Now, if amines, or if a primary amine of this type, RNH2, reacts with H3O plus or H plus, or a proton coming from an acid, what's obtained is the corresponding ammonium ion. So this is the ammonium ion, and of course this is a primary amine. We could have a secondary amine, of course. This is just an example, a primary amine. If it picks up a proton from an acid, of course the corresponding ammonium ion is formed. Now, to discuss basicity, BKB or minus log, the basicity constant can actually be used, but in organic chemistry, what's used is actually the pKa of the conjugate acid. Remember, the amine is a base. It's a base, and of course the ammonium ion is the corresponding conjugate acid. Now, strength or weakness of the conjugate acid, and as an acid, reflects the amine basicity. If this is a strong base, a strong acid, therefore this reaction is not likely. So the opposite reaction will actually be likely, and therefore the amine is not basic. If this is a weak acid, so this reaction in the way it's drawn in the forward direction is possible, and if it is a weak acid, therefore the amine is basic. So if this acid is strong, the amine is not basic. If this acid is weak, then the amine is basic. We can use pKa of the acid. Chemists use pKaH to denote the acid strength of the ammonium ion. So if the amine is a strong, base, then this is the ammonium ion is a weak acid. If the amine is weak base, therefore the conjugate acid is a strong acid. And of course, in organic chemistry, acids, again, acid strength is denoted by pKa. We use pKaH. So of course, if the acid is weak, therefore this would result in large pKaH. pKaH, that's the term. pKa, of course, minus log the acidity constant. H to denote or to describe the conjugate acid of the amine. So the pKaH basically is minus log the acidity constant of the ammonium ion, if you like, or the conjugate acid of the amine. If the pKaH is large, therefore the ammonium ion is weak. If it is weak, therefore the base or the amine base is strong. If the ammonium ion is a strong an acid, therefore it should have a small pKh, and if it has a small pKh, therefore the original amine or original amine substance is a weak base. So therefore, we use pKh. If pKh is large, then the amine is a strong base. If the pKh is small, then the amine is a weak base. Organic chemists prefer to use pKh, or the acidity constant of the ammonium ion, or the conjugate acid of amines, rather than pKb or minus log, the basicity constant of the amine itself. In summary of this, amines are basic. That's because nitrogen has a lone pair. Again, that lone pair, not only it makes amines nucleophilic, but also it makes them basic. In organic chemistry, the basicity of amines is described using pKh or minus log, the acidity constant of the ammonium ion, or the conjugate acid of an amine. If the conjugate acid or the ammonium ion is weak, therefore a large pKh, then the amine is a strong base. If the ammonium ion or the conjugate acid is a strong acid, therefore a small pKh, therefore the original amine is a weak base. So that's a very useful way to describe basicity of amines, and that is the pKh or minus log, the acidity constant of the ammonium ion, or the conjugate acid of amines.